Hello, good afternoon. Um, I don't usually ask in my talks because it's a mix of API and serverless conference. How many of you are with serverless, doing something or thinking of doing serverless? Oh, okay, perfect, excellent. Um, Last week I was at a serverless conference in New York, and during the conversation with a couple of engineers from an organization, so during the chat, they came to know that I'm talking here today about patterns. One thing they mentioned was they've been to a couple of patterns talks, but usually they see all these wonderful patterns laid out and few, architectural diagrams shown, but they never really connect with a real use case they can understand or take away. So in this talk, the patterns will be associated with some real use case that we've been through at Lego, so that you may be able to relate that in your own domain or the applications that you work with. So that's how I placed this talk today. So let's see how it goes. My name is Sheen. I'm one of the engineers working for Lego within their e-commerce side of business. So we call shopper engagement technology. So predominantly we run the lego.com site and all the technologies associated with that platform. So we've been doing serverless for a few months now. So this talk is based on our experience in doing serverless. I'm at Lego for the last 3.5 years, and before I've been through a few of these companies where I spent most of my career with. And these are a few of the talks I usually do these days at different places, mostly around serverless and Lambdas and things like that. And later this year, I'll be speaking at reInvent. So a mix of what you hear today, also coupled with the experience what we've been through, along with our AWS friend Danilo. And you can follow me on Twitter, and occasionally I blog on our Medium channel. So I'm not going to talk about what is serverless and give you the definition and et cetera, because I can see that you all been through serverless. And also this is an architecture conference, so I don't need to go the basics. So let me start with why serverless, and let me give you a different perspective from my, my thinking. So first thing is, it's an ecosystem of managed services. So what I mean is, when we say serverless, we often think that it's just the Lambda functions or function as a service, but often forget all the other managed services that we need to use in order to get a serverless platform up and running efficiently. Things like DynamoDB or an S3 or SNS, SQS, you name it. So all those things together, to me, make us an application as serverless. So then we have this capability of optimizing at function level. So that means, so you have a bunch of Lambda functions, and each function can be optimized or tuned specifically to cater for that particular function. You don't need to tune everything, or we never do that in serverless. So we get that sort of capability. So for example, when we have a customer-facing Lambda that needs to be, pretty fast and quick in responding, we may be giving extra resources in order to carry out the task quickly. Whereas if we have a Lambda which runs once in a day at night, the performance is not critical, so we may, the resources we allocate in terms of memory could be a bit low, even if it takes a bit longer. But there is a balance in terms of costing and things. So that's what I mean. And then we have this capability to go with the iterative development. So that means we don't need to go with the big bang, everything now approach. Rather, we can start something simple and small and slowly improve or scale from there. So we get that capability with a serverless approach. And then finally, this is one of the important things as far as I'm concerned. It gives the diversity to the teams. So that means engineers are no longer doing a C++ or a Java or a JavaScript programming. They also take ownership of the whole thing they do. So they write a Lambda function. They need to configure the security aspects of it. They need to wire it up with the SNS or SQS and all the other things. So they kind of spreading the knowledge beyond just being a programmer. So that sort of capability that comes with the serverless and cloud. So this is how I see why, few of the reasons. Of course, there are tons of other reasons why we want to move to serverless, but few of the reasons that I just wanted to bring it to you. So as I mentioned, we've been doing serverless for a while. So before I get going with the patterns, let me give you a kind of status of where we are. Okay? So 1 year ago, around August last year, we had no serverless, no Lambda functions, nothing. Clean, empty. So then this Lambda, this was the first Lambda, this came into production around September timeframe last year. So from there, we moved on pretty fast. Within the next less than 9-10 months or so, we switched our shop.lego.com from an on-prem monolith onto a serverless cloud-based solution. So this is not a kind of lift and shift migration. This is purely greenfield cloud-native implementation on AWS cloud. So this happened. So just over a month since we launched this one onto serverless, we merged two domains. So that means at that point, if you wanted to do Lego shopping, you go to shop.lego.com. And if you wanted to look for details about Lego or children's play kind of things, you go to lego.com. So business wanted to bring them together so that you get an unified experience when you go to lego.com. So this happened within a month since we moved the platform to serverless. So this kind of proved us the speed and agility we can have with serverless in terms of pushing the solutions forward. So this then opened floodgates to us to incorporate and to come up with various solutions as the business needed. And over the course of the time, we have used all these and few more services from AWS. And in terms of accounts, this probably is grown further. So we use these sort of roughly this number of Lambda functions and services and other things on AWS. Of course, for us, this is just a starting. So there are more exciting projects and more features and things that are in the pipeline. Team are quickly producing the solutions. So if you look back, where did we start? So usually you hear about the monolith. Of course, there was a villain like monolith. All right. So the monolith for us was age-old Oracle ATG e-commerce platform, which is in the the middle part. So it went through a few sort of TLC or a bit of touch-ups. So they put a wrapper REST API around, and the front end from JSP, it moved on to JavaScript, React, those kind of things, and running on Elastic Beanstalk. But the middle part was still a monolith. So if you wanted to change anything and deploy, you have to deploy all the 120 APIs and everything that goes. So it used to be a pain those days. And we also had a third-party API gateway to manage the APIs. Though it was running on EC2. The engineering team had nothing to do with the management of the AWS EC2 instance or anything. It was completely away from the engineering team and maintained by an infra team somewhere else. So then the Lambda came along, the one I showed you earlier. So the reason why that Lambda came along was because we had a dramatic failure on a Black Friday. So the whole system failed and the shop went down for 2 hours. Simply because that tax system I mentioned there, it's a cloud-based now, but it used to be an on-prem solution. And the SAP's connection to that tax system failed. The tax system is mainly for calculating US and Canada taxes. So that decoupling happened when the failure happened on the Black Friday, and the whole sort of business discussions and blames and whatnot you can imagine in an organization. So we decided that let's put that away from the on-prem. Let's go to their cloud solution. So how do we get to there from ATG? ATG at that stage was earmarked for replacement. Upgrade or put something new wasn't decided. But we didn't want to do any amount of work inside ATG. So we wanted to do the minimalist possible thing. So that's when we decided to put a Lambda, the one I showed you earlier, the first Lambda that came into the picture with an API gateway. So this became a very successful thing. And the next Black Friday, which was the last one, which was perfectly fine. And this Lambda scaled, as it should scale, and everyone was happy, and that's where things started to happen. So that's when we started into the full serverless mode. So over the months, so we came up with this sort of a rough high-level architecture. So the things on the orange things, Lambdas on the side, those are our serverless microservices. And in the middle, we have a GraphQL layer, and then the Node React front end. They all run on ECS Fargate. So, and to just give you a simple view of that, so this is how it is. Oops. Yeah, so this part there, those are the microservices, all serverless. And this is the GraphQL layer in between and the front end. So Graph just acts as a data layer. We don't keep any logic at all in the Graph layer. All the logic, everything lives in the microservices layer. So this is another way of looking at it. So just a few microservices. I think there are a few more. And a couple of things to note here. We made the decision that between microservices, the communication we do is always via API calls or events or messages. We try not to invoke a Lambda from one microservice to the other one, because things may get complicated. So that's why we kind of have that policy in place, and that's the way it communicates between the microservices. Right. So this is some sort of, the Spiderweb diagram we have. So let's move on to patterns. Traditionally, when we talk about patterns, you must have read more than one of these books. So usually the Gang of Four book is kind of the source of truth for all the patterns. So they talk about Strangler pattern or facade or this, that, etc., etc. You see that sort of gray class diagrams and this and that look complicated. But luckily with serverless, we have more color. True, right? Because at least AWS have given us more icons and this and that, so we can easily put things together and make a picture pretty. So that's one thing. And then if you look at the different sort of definitions and the purpose for patterns, we all know that it's sort of a repeatable thing that gives you the speed to move forward with the design. Once you've done something, you can copy it and take it forward. So patterns has a name, and it has its own few characteristics. And if you use the pattern wisely, it's good. If you use the pattern wrongly, then you get the consequences. And people started calling serverless also as a pattern. That's fine. So the way I look at it is, like, if you look at the programming patterns and the architectural patterns, I see the serverless patterns kind of in the mix in the middle. So you get something from here, from there, and make it more colorful and beautiful. You have these serverless patterns. So let's move on. So let's start with a very simple pattern. So this is a request response pattern. Obviously, you must be all familiar with the simple API. So you make a request, get a response. So a simple use case is when you go to a online shop, put something into the basket. So that's a simple API call, add thing to the basket. So the thing is, behind the scenes, the bunch of validations happen, right? So whether you are eligible to buy these products, or how many you already bought, how many are already in your basket, and so on. So this needs to be very performant because you can't make the customer wait there for longer. As we just heard, these days, 3 or 4 seconds is the time you have before things happen. Otherwise, they just move on. So this is a simple pattern where if you look at the pattern itself, there's a Lambda, which does the business logic thing, and then you have an API gateway in front of it. So you request the API, hits the Lambda, it does something at the back end with your data store or commerce platform, you get the response back quickly. So this is a simple request response pattern. Now let's move on to a slightly different one. So this is also a request response pattern, but the difference here is that you get acknowledgement. You don't get the response payload that you can use to do something. You just get back a simple, okay, I got it. Yeah, I will do something. Then the processing will happen behind the scenes. So the scenario, the use case here is newsletter subscription. This is a typical thing. You go to a website, you put your email address, click, subscribe to email or, send me the newsletter. And the website will say, okay, I got your request. We will send you in a week or 2 or whatever. So that is this pattern, the simple one. But if you look at the architecture behind it, so there is an API gateway. So there is an endpoint that the front end or the app calls. It goes to a Lambda. So a Lambda may be performing certain validations to make sure that the email address is correct or this, et cetera, et cetera. Then what happens is it completely decouples it. All right? So it sends a response, an acknowledgement back, but behind the scenes is pushing that into a queue so that that process from that queue onwards happens completely asynchronously separate. So this is another pattern, it's quite common. So when you put that into the queue, then a Lambda that is listening on the queue, basically, if you're familiar with AWS, you know that there's a trigger for, SQS trigger for Lambda. So that then gets processed, things done. Let's move on to a slightly involved one. So this is an async notification pattern. So the previous one we saw, acknowledgement, and something happens in the background. In here, this is also like that, but there is more stuff happening in the background. So the voucher generation is like, if you can think of the discount codes you get from the shops. So for that, we need to generate that many number of voucher codes, depending on how many millions of customers you have. It could be hundreds of thousands of discount codes or millions of voucher codes you need to generate in your system. And that will then go on to different processes. Sometimes you need to print them, you need to email to customers, you need to keep them somewhere so that when someone redeems the voucher, you should know that the voucher you supplied that it's a valid, not redeemed, et cetera, et cetera. So for this, so if you look at this one, so this will be triggered not by an ordinary user, so there'll be a management admin user or business user who will will have the authority to generate that many vouchers. So in our case, we have an external third-party system which basically sends out the vouchers to customers. So that means the vouchers that we generate, voucher codes we generate, needs to be sent to the third party securely as well. Okay. So what happens here is someone invokes the voucher code generation, voucher codes get generated, stored somewhere, then the admin will be notified via an email that your vouchers are now ready. You can go here and download and then do whatever you want. So that's the sort of the pattern. So if you look at the pattern itself, so the admin user is invoking an API. So that pushes that to a Lambda to handle the request. And then this Lambda will do an acknowledgement and asynchronously invokes another Lambda. So this is the Lambda which will, the second Lambda here is the one which will generate that number of vouchers asked for. And it will push the vouchers into DynamoDB because that's where we keep the voucher code so that when the request comes to redeem, we can check against the DynamoDB store. And then it keeps the vouchers as a file format, in S3. That allows us to generate a signed URL, which will be valid only for us, a certain period of time. That URL then will be emailed back to the requester via an SNS topic. So, the SNS topic, it will send a message to SNS topic with the signed URL S3 object key, and that will then be emailed to the admin user. When the email is received, it will have a link. All they need to do is just click. They won't have the they won't have any access to AWS at all. They won't have any AWS account. They are completely outside of AWS setup, so they can download and get the file and send to third party or do whatever they want to do. So this is slightly a different pattern. Now, Lambda Authorizer, I don't know whether you are familiar with this or not, but API Gateway allows us to validate or authorize, authenticate the incoming request in different ways. One of the ways is to have a Lambda Authorizer behind the API Gateway so that before your request is sent to the business Lambda or the Lambda that actually does the business side of things, there will be somebody sitting there as a gatekeeper to make sure that the incoming request is indeed a valid request that can go further. So in here, the example here is that, so I talked about the discount codes and voucher code. So we have the rewards account set up. So this is external. So when a user comes to our site, so in Lego, we have a Lego identity. So every registered user will have a Lego identity. So that becomes our first check. So we will check that, okay, are you a Lego identity customer? Yes, then we will see if you are coming with this particular reward account request, okay, do you belong to us, and do your account belongs to us? That check also needs to happen. So only then the request will be passed along in order to view the account, the rewards account. So that is the use case here. So how this will work as a pattern in AWS is like, okay, so the request comes in. So the front end will first, as the customer logs in, will get the Lego identity. It will have all the OAuth tokens and etc. etc. Am I done? Hello? Yeah? Okay. Right. So that will send the tokens to the API Gateway as part of the request. So API Gateway has this authorizer specifically for as a gatekeeper to check. So that authorizer will receive the token, okay, make sure that it's a Lego ID, and it will also cross-check with a commerce platform to make sure that the user is who he says or she says is before the request is handled or passed on to the the business Lambda. So this is a very common pattern. I mean, this is the simplest form. I mean, it can be complicated with if you have Cognito or a third-party Auth0 or other mechanisms. It can be complicated as well. But in simple form, it just works. So that means, invalid access can't go past the API gateway to the business. Right. Yeah, so that's the part I was talking about. So this is data pipeline. This is a very common pattern if you work in serverless, especially with S3, Lambda, and etc. So for us, the use case is that, so we have a new commerce platform now, which is a third-party headless API-based platform. And for us, all right, I'll keep talking. So for us, the product data, for example, comes from SAP. SAP still access the source of truth for the product data. So we need a mechanism to ingest or receive the incoming feeds from SAP, transform the feeds, and then insert or update the details in the new commerce platform. So this is roughly how it will look like. So the feeds will come in, do some magic in between, and then update the commerce platform. Then the website will then pick things from the new platform. So if you look at the pattern, the way it works is SAP, on that end, they will drop the feeds as JSON feeds into an S3 bucket. S3 bucket has a trigger setup. So as soon as a file is dropped in S3, it will trigger a Lambda function. And the Lambda function will then read the data, do the transformation as closely matching for the commerce platform. Then it will push that onto a queue. So from the queue, there will be another Lambda, which will then get triggered. And the second Lambda's part is purely to interact with the commerce platform, whereas the first Lambda doesn't know anything about the commerce platform. It only picks up the data from the bucket, does the transformation. Now, the problem is we have around 20 different data feeds, 20 different types of data feeds. So each type has a prefix, so file name, name like a product master or SKU or inventory or something like that. So in S3, if you're familiar, you can set up trigger based on prefix, suffix, etc. So that means if you want to handle the inventory feeds, you can set up a trigger just to look for inventory and invoke this particular Lambda. So that will, so in here, this middle part I'm talking about. So this is a pattern, standard thing. So once you have this in place, then you can have a number of feeds and you can have individual pipelines dealing with each feed. So it looks something like this. So I think we have 6 or 7 more pipelines. So this is really cool because every feed is dealt in its own pipeline. So if you want to monitor certain pipelines, if any failures, like for example, master data is an important feed, right? If anything fails, then we can set up a monitoring on the queue, data letter queue associated, and we'll get alert as per the setup. So this is really cool. So that's data pipeline, a very common pattern, very efficient pattern involving S3 and Lambda triggers. So this is a functionless pattern. It's kind of one of my favorites because I also talk about reducing Lambda footprint in a different talk. So the point is, in AWS, there are a number of ways you can avoid writing Lambda functions and still do the same thing. So this is one example of how we do that. I mean, there are many places we do, but this is one example. So this is about ingesting clickstream event. So if you're familiar with websites, you know that as a user comes onto the site and goes through the site, every action is tracked behind the scenes. they would know exactly where you clicked, which product you looked, and et cetera, et cetera. So this is known as the clickstream events. So we collect the events behind the scenes, and we kind of stream off the events through a pipeline. And those events go to different places. One common destination is your recommendations engine. So based on your clicks, the recommendations engine will receive the events and work out what recommended products needs to be shown to you. So that feed will come. So you will see suddenly, oh, here are the products for you, you may be interested, etc. So this is one typical case where we ingest the incoming events and send out to different consumers. So if you look at the AWS pattern, this is one way of doing it. So we have an API to receive the events in the sense small JSON files. And then you could have a Lambda behind the scenes to receive that events and then push to a Firehose. We use Kinesis Firehose for streaming. And then it goes through S3 bucket, and from there Lambdas pick up and do all the processing, etc. But this can be better because this Lambda here is not needed, because in our case, this Lambda is not doing any processing at all. This is just receiving the data and pushing onto a Kinesis. So that can be done without having to need the Lambda in that place, because you can integrate API gateway directly with the Firehose. So there is a bit of, depending on which service you integrate, you may need to write a few lines of velocity script behind API gateway, but that's fine, because you're not adding an extra Lambda, then looking after its maintenance and all the rest of things. So this is not many people know, especially when they come new to AWS and serverless. There are, I think, over 40 services you can integrate directly with API gateway. So we have S3 integration, SQS, SNS, Firehose, and Dynamo integration as well you can do without a Lambda. So that's one I call as a functionless pattern. So moving on, order number generation. If you are from the traditional database side, relational database side, especially with Oracle, so you know that if you wanted to generate sequence numbers, you can set up a sequence number object and things, and in Oracle you get the next number. When it comes to serverless, it's not obvious how we can generate this. So especially, say for example, in our case, we need to somehow generate the order numbers. So in our order numbers, we generate them in a sequence number. Similarly, say for example, if you have a, candidate registration number, you may need some sort of a sequence number generation mechanism. So one way to achieve this is using DynamoDB. So I did a blog on this one, the number generation mechanism. So with the DynamoDB, we have this atomic number feature. So that means you can set up the script to generate the number so that you don't get the duplicates or anything. I mean, the good thing is that it's a very simple table. You can have a table with one ID, and you just put a number, starting number, and then have something like this, the script. Then you'll get the auto-incremented number. The thing is, you don't need to go to the next number. You can even skip. You can go by 2, or you can even go in the reverse order. It all depends how you write the script there. So that's all. So this is very efficient. We have in 2 or 3 places where we have the sequence number generation happens for different purposes. Again, as you notice here, there is no Lambda involved there. It's just directly integrating API gateway with the DynamoDB. Right. So this is fan-out pattern. This is a very common pattern, again, in serverless, because you can asynchronously invoke a bunch of Lambda functions. So the clickstream event ingestion I talked about earlier. So this is basically the other part of that event ingestion. So on that end, you have the the producers who can send events to the event stream. So we ingest the events, process the events, and then send out to a number of different consumers. If I showed you the pattern, so this is that part, the API gateway kinesis we already seen. So then from there, S3. So with kinesis, if you're not familiar with kinesis gives us the option to batch the events. So say, for example, you can batch to the minimum possible of 1 MB or 1 minute up to, I don't know exactly the limit, but there are a few MBs and I think maybe a couple of minutes as well. So that way you can plan your things. So for us, we have the 1 minute, 1 MB, because for us, we need to send the events as quickly as possible to the recommendations engine. So that also really helps so that we can tune the Lambda behind the scenes so that it will always get 1 minute worth of data or maximum 1 MB data. So the data then, once batched, is dropped into S3 bucket, and from there is the known story that Lambda triggers. So this events triage or Lambda is basically, what it does is, we have a number of different event types coming in. So it could be checkout event or checkout complete or product clicked or whatever. Now there are different consumers, they are interested in different types of events. So we need to first put those events into different batches before sending out to the respective consumers. So that identification is set via a symbol JSON file. So that means if we have to add an extra consumer interested in a particular event type, we don't need to touch any of these things there. All we need is update that JSON script, add the new Lambda to send the events. That's it. The rest of the things will work. The new thing, as soon as this is in place, that will also start working. So that's why I call this as a triager, because that kind of triages the events. And then it fans out to a number of different consumer Lambdas to take the events to the destination. So this is that part I was talking about. And that is the JSON script I mentioned, where we have event type to consumer Lambda mapping. Right, so this sitemap generation, the pattern I'm going to talk about is a very simple one. So you must be all familiar with cron jobs and schedulers. So sitemap generation happens once a night. So it's basically there is a CloudWatch scheduler rule which triggers something to do that. The sitemap generation is basically for crawling and Google search, all those purposes. You need to kind of scan all the products and categories and keep them in sort of XML files in somewhere so that Google or whoever else can come and find them. So simple. So someone is triggering a process, then sitemaps generated, kept in a file store, and published so that everyone can see. So the pattern here is with CloudWatch rule, you get trigger a step function. So we use a step function to do this thing in parallel. So we have the product map generation as well as category generation happening in parallel, and then they come together, wait for things to finish, and then it goes to an S3 bucket, and S3 bucket then will act as the origin server exposed to external via Akamai. So that's so basically this this part is the scheduler part. That's all, and the rest are all just to show the step functions. So in parallel, these two happen, and then the files are kept in a S3 bucket, and from there it is exposed as a origin server via Akamai to the world. So That's the sitemap generation and the scheduler pattern. So this is another simple one, which is basically the SNS topic subscription mechanism. But the use case is a bit involved, so let me explain. So when we moved from the old platform to the new platform, obviously there were tens of millions of customer records that we need to migrate, right? So we were debating whether it's worth migrating tens of millions of customer records from the old platform, and also we also have the same data in SAP as well, onto the new platform. Then there were questions. What if millions of customers, they moved on? They created new profiles, or customers who never come back to the site. Why do we need to migrate all those things without any knowledge onto the new platform? We kind of going to keep dead data there, no longer to be used. So we went with this sort of bold approach, saying that, okay, let's do one thing. Let's do on-demand migration. We won't migrate millions of records upfront. We will only migrate the user data when a user comes to the new site. So that's where we use this. Obviously, there are a number of places we use, but the pub sub mechanism. So this is what I was just explaining. Customer coming to a new site, new platform, and gets notified somehow, and that triggers a process to fetch the data from SAP and then push back to the new platform. So if you look at AWS pattern, is a very simple one. So there is this topic, SNS topic. So the trick here is that as customers come into the platform, they don't obviously have a profile in the new platform, but they will have Lego identity. So we will take that details from Lego identity, whatever they have, and create a skeleton profile initially in the commerce platform when they log in. And that will trigger a message or event onto our topic. So that will then kick off this Lambda to perform the data fetch from SAP and then push that into the commerce platform, basically enriching the skeleton profile which was just created. So this worked so far beautifully. So we kind of avoided the mass migration of the customer data onto the new platform. So this is order status polling. So this is typically like when you go through an online shop, you put things into a basket, and then you made the payment, and you click submit, and often you get a delay. So what happens during that time? What processes happen behind the scenes? So if you look at a typical thing, so you have a basket, you have things, and now you are ready to pay. Now, for an end user, this may look like a seamless, synchronous thing. But one of the hardest thing or the time-consuming thing behind the scenes for any e-commerce is dealing with the payment provider, getting the payment sorted. You do all the token exchange and this and that. That takes time. So most cases, that's where we usually put some sort of spinner or some way of entertaining the customer, and it will be done with the payment processing. So how do we notify this to the front end? So that's where this pattern comes in. So if you look at the AWS side of things, so that's the order submission happens. So there is a Lambda that picks it up, and that pushes into a queue because we can't hold that for longer. We need to just move on. So that then gets to another Lambda that deals with all the the payment authorization and dealing with the I don't know, whoever is behind the scenes performs the validation and everything. And what happens is that Lambda keeps its updates status updated in a DynamoDB. So that acts as a cache. So in here we have an API. So as soon as the order is submitted, the client or the front end will start polling the order status API for the status. So basically, the status like you can say that I'm still processing or failed for some reason or it's complete. So the thing to note here is if you've been through, you may know, but other thing is that not all the status details can be revealed to the front end, especially when it comes to payment for fraud reasons. So we will have this sort of the bulk ones as the main status going back, but the dynamo behind the scenes will know exactly what happens. So it could be a failure, but could be a validation failure or payment failure or whatever. So that's how the shop works. So, and obviously the front end will have some sort of a timer so that it won't go on polling for ages and things like that. So URL redirect. So I mentioned earlier that we merged two domains together to become lego.com. So behind the scenes, there is a Lambda which will basically redirect any URLs coming with the old domain to the new one. So it uses sort of a caching. It's a so performant Lambda which is behind an ALB, a load balancer. All it performs is, so we have this sort of the URL mapping in our content store. So it will grab those things and cache them locally in memory as well as using the Lambda storage. For us, that's enough because our, the map size is less than, what we need. So, and it performs. So the highlight here is to notice that, so the Lambda has a temporary storage. Not many people make use of that. And also it is possible that if you allocate the resources appropriately, you may be able to make use of the Lambda's memory as well as part of your cache. So this Lambda, when it starts from cold, so it will start building the cache. So once it's up there with it, it's so performant. So I think I have some timing here, yeah. Averages 2 to 3 milliseconds to deal with once it's warm. I mean, for us, there will be 2, 3 Lambdas always form. So it's not an issue that every request is hit by a cold start or anything. Right, so coming to my last one and favorite. It's a hub and spoke pattern. So I don't know, you may be aware that recently AWS released or made the event bus public. Or that means we can create our own custom event buses. Always had one. That's how all the CloudWatch events and things go through. But now we can create our own event bus. What that gives us is the ability to unify the microservices to microservices communication. So if we go through this picture, so we have this number of microservices. So they talk each other via events and messages and whatnot. So typically what we will have is we have sort of SNS topics put on places, and suddenly we realize, oh, this topic is not good, this is doing for that one, let me do another topic. So over the time, we will end up having so many different topics all over the place, then everything becomes a mess. So with EvenBridge, what it gives us is this sort of the unified way of routing the messages to different destinations, not just between microservices. There are a number of 13, 14 AWS services, and also you can send to other event buses. Third parties involved, like, I don't know, there are a few monitoring and alerting partners who work with AWS. You can, send the messages to them as well. So this is a work in progress because it only happened now. So we are slowly trying to put this in place so that we can make our microservices communications better. Now, it depends how we structure the events. For example, in our case, so this is a template for an event structure. The top part are Amazon AWS specific ones. So the detailed part is where we can keep our data. So what we do is we have a sort of a standard structure in here. So we split the details into two sections, metadata and the actual data, the data that flows through. That allows us to perform filtering in a more a standard way. So that means this becomes sort of a standard static part. That means, so if somebody is sending an event, they will know exactly what subtypes they need to use, what types and status they need to use. So that means when we set up the filter to receive a particular event and take it to a Lambda or take it to another queue, we know exactly what to expect. Whereas this is more implementation specific, whatever data, without exposing the personal identification or other sensitive details, we can put those details there. With EvenBridge filtering, the other, I don't know whether you have looked into it or not, it also allows you, when you set up a filter rule, there are two parts to it. There is an incoming input part and it's an output part. So the input will be the event coming in, then you apply the filter. Then you don't need to send the same event to a consumer. You can substitute with a dummy event or some data or just with the junk data. Or you can even transform the data that goes to the consumer. So that way we have the flexibility to play around without revealing, say, for example, if you are streaming the payment failure details to a Lambda or another queue, for example, whereas you don't want to reveal the exact message to this place because you don't know where that data is going to go. So that means you can just simply say that, okay, payment failure. That's all I can say. So that sort of gives the flexibility for us to set up the routing mechanism. So that's all about the patterns. So today, I mean, there are a number of different patterns we can talk about. So when you kind of go from old platform to a new platform, obviously you will go through these triangular patterns you see. And also you will have these sort of circuit breaker patterns, especially when you deal with the external services where you don't want to bring your site down because that external service is not available. So there are a number of things. I mean, obviously you can come up with your own patterns. So we don't need to go by the textbook style patterns. We can have our own patterns. So a few things before I wrap it up. So if you are doing serverless, it's worth keeping in mind a few of these points. So first thing is have some principles in place. Say for us it was like, okay, we do serverless. We will use managed services everywhere is possible, and we will use this framework this way. So that means across the team, everyone is on board. They will know exactly what our objectives, what our principles. There won't be any arguments or anything whether we do that or this or that. Sometimes painful decisions, but once we have this in place, it really helps to move forward. And then sensible solution. This is important because especially when engineers come on board with the new technology, always the excitement, right? So everyone wants to try to do the best possible. That means sometimes it can drag on and on with the discussions with the never-ending solution. Just come up with something, get going, then you can always keep iterating. So that's very important. Architecting set pieces. So this is kind of set piece is my term. What I mean is so you need to have the entire vision for what you're going to have. But when you start focusing on particular thing. So if you're focusing on data streaming, that part, just focus on that part. And what you can do is that you can rehearse that, you can replay, once you have the setup in your sandbox, you can basically run that however many times you need to imitate how it will be in production. So that's what I usually say, that the set piece architecture rehearsing part. So that means you know exactly how to tune the Lambdas or other resources before you take that solution to production. And then cost awareness. This is very important. I also do a separate talk about serverless costing. This is important because for engineers to know how the Lambda or serverless costing is worked out, make them more efficient in terms of when they provision resources for Lambda or set up DynamoDB scaling aspects and so many other things. Proof of concept is good. if you have the time, it really helps if you wanted to show something to stakeholders and get their buy-in before you press on with the actual implementation. It doesn't need to be a throwaway prototype. That's the beauty of the cloud. You can start doing the real thing in your sandbox or in your dev environment and show it to the stakeholders. And if they say, the next day you can push that to production. So, so that really helps to buy in. And act fast. Don't just sit there and debate for days or think about days. If you're thinking of moving to serverless, just go and do it. Check if it works or not. If it doesn't matter. You move on. If it works, yes, fine, make it better. So yeah, just do it. That's all I have. Thank you so much for your time. Hope you learned at least one or two things on serverless. And if I encourage you to do more on serverless, I'd be very glad to hear. Thank you.